Hi, everybody. So this is going to be your first video for this class. We are going to go over significant figures. So some other science classes just ask you to use 3 or 4 sig-figs on all of your answers. But in AP Physics, we're actually going to figure out how many sig-figs each problem is going to require. And it's going to it's going to rely on your measured numbers that you're given in the problem. So first, let's use this example to show why sig figs actually care or actually matter in the real world. Why should we care? So measurements all have physical limits. In 2016, there was at the Olympics there was this three-way tie in the 100-meter butterfly with a time of 51.14 seconds. Now, this caused controversy because people asked, why are we not just measuring down to the thousandths place? That would settle this. Or why don't we just go to the 10,000ths place if they tied at the thousandths place? And there are scientific reasons why they didn't do that. Now, let's go into that. Why could the tie not be settled by timing to the thousandths place? Well, first, let's brag. Phelps does have the world record at 49.82 seconds for the 100-meter butterfly. That was not shattered at this time. They did set an Olympic record, but Phelps had a faster record for the world record. Now, the Olympic pool length is 50 meters. The Olympic pool has to be 50 meters long. However, there's some error there. You can have an error of 0.03 meters, meaning you can be longer or shorter than that 50-meter mark by 3 centimeters, or 0.03 meters. So that means that one of those lanes could be 49.97 meters, or one of those lanes could be 50.03 meters. So there could be some leeway there on that measurement. And that's just the error that they use to call it an Olympic regulation pool. So the pool is measured with 4 significant figures. It can either be 49.97 meters long, or it can be 50.03 meters long. Those are all measured with 4 significant figures in their precision. Now, if we time anything in that pool, it needs to also be held accountable to 4 sig-figs to be precise. And we do. They are timed at 51.14 seconds. So if we went to the thousandths place, that would use a 5th sig-fig. Now, that would not be correct to measure their time in the thousandths place, because as Michael Phelps, maybe he had a shorter lane or a longer lane than the other guys that got second place. So maybe he really did swim 100 meters at a little bit faster than somebody, but maybe his fingertip didn't touch it a thousandths of a second faster. So that's why we can only use the sig-figs that the physical objects or physical measurements have set out for us. If you try to use a more precise number than your tool, or a more precise number than the object was measured at, then you're doing invalid science. And that's why that they could not settle this 3-way tie. All 3 of those guys, they went home with silvers. 2 of them were probably mailed home. I don't know that they keep those spare silvers on hand. Okay, so next, does the AP exam care about sig-figs? Yes, the AP exam does care about sig-figs. They will, not on every problem, but on some problems, they will ask you to use or round using the appropriate significant figures. Now, you have to know what that amount is based on the numbers that they give you. And we'll go over that on the next slide. Why does Mr. Pentecost care about sig-figs? Well, I care about sig-figs because if you're taking AP Physics, you're probably interested in science and probably going to do a scientific related field. So for example, if you're an engineer and you screw up your sig-figs, you're either too precise and you're making assumptions that you really can't follow up with, or you're not precise enough, and your machine is not going to function the way it's supposed to. So Sig-figs are very important when you actually enter a scientific field, and knowing how to determine Sig-figs is equally important. Now, number 3, this one's up for you to answer. Do you actually care if the AP exam or Mr. Pentecost care? Now, when I grade your unit tests, I will grade using Sig-figs. If you have the inappropriate Sig-figs, even though you did all the math right, you may lose some points on that. Same for the AP exam. You can do everything right, but if in their grading scale it says their number has to have this many Sig-figs, you may lose a point or two. Hopefully you care about that. If you don't, that's a real bummer. You should care about that. Number 4, my ruler is marked in centimeters. Do I report in centimeters or millimeters? Now, some rulers will have those tiny little millimeter marks, so you can actually see which millimeter mark are you closest to. That's not the case on all rulers. So if you don't have those millimeter marks, should you guess and say, well, it's kind of at the quarter, maybe it's a quarter past or a half past or 3/4 past that centimeter mark? You can't make that estimate. I mean, you can make that estimate, but it's not a valid way to make your measurement. Your valid measurement would be which line is that measurement closest to? That's your centimeter mark. So it may look like it's 14¼ centimeters, but you're going to put down that it's 14 centimeters because that's what your measuring tool can actually tell you. Now, if you want to measure more precise, get a more precise tool. But I don't have that nice of rulers. Number 5, what is the rule when measured numbers are multiplied or divided? Which is going to be super common on your assignments. So when measured numbers are multiplied or divided, you will use the least amount of Sig-figs used in those numbers. So say you have a number with 3 Sig-figs and a number with 2 Sig-figs, and you multiply them together, you've got to use the 2 Sig-fig answer. Now, if I were you, I would do the problem as precise as you'd like and wait until you get your final answer to actually round. Because if you start rounding all the way through every step of your way through the math problem, you're going to get a different answer. So don't round until you're completely done. Then next, number 6, what is the rule when measured numbers are added or subtracted? This is a little different. You don't use the least amount of Sig-figs to round. You use the least amount of decimal places to round. So we'll go over that when we actually get some problems. But we are going to worry about the multiplying and dividing a whole lot more in this class. And once we get to our first take-home test on our first unit test, I'll help you guys out to make sure that you guys understand what's expected there. All right, next. My way of counting Sig-figs. So this is the way that my physics teacher in high school taught me how to count Sig-figs. I don't think I've gotten any of them wrong. I've never ran into a scenario that this didn't work. So you've got 2 numbers, 009133.60 and 913,360. So when do you count a number as significant? When you're counting all of those little digits in there. So this has one of those little mental mnemonic kind of things. If there is a decimal present, you start counting from the Pacific. So you'll start counting from the left if there is a decimal, because the Pacific is on the left of the United States. That's why I gave you the little map. So the decimal is present on the first number, 009133.60. So the rule is to always ignore zeros that come before the first integer, then count until you're out of digits when the decimal is present. So let's start from the left. 0, you don't count it. 0, you don't count it. Then you have 9, 1, 3, 3, 6, 0. 0 is a digit, so you keep counting it if it's after a decimal. We assume if it's after a decimal, it's been measured. For example, if you're going to measure something that's 9¼ inches, you would say it's 9.25 inches. You would not say it's 9.2500000 inches, because you don't know that it's actually that precise of a measurement. So if there is a 0 after a decimal, it's significant because we assume that it is actually that precise. So that's if there's a decimal. If there's not a decimal, if the decimal is absent, start counting from the Atlantic. So you start counting from the right of the number, or basically start counting from the end of the number. So again, always ignore the zeros until you come to your first integer, then count until you're out of integers. Don't count until you're out of digits, because sometimes there's some zeros just sitting at the front of a number for no reason, like the number I made up there. But we'll start counting from the right. So for 913,360, start counting from the right. You have a 0. You don't start the first, don't count the first zeros. Then you have 6, 3, 3, 1, 9. So that has 5 sig-figs. The other one had 6. And then you wouldn't count any zeros that came after that 9. But that's how you can always remember to count, how you can count sig-figs, whether there's a decimal present or absent, because it's very different if there is a decimal there. Decimal and non-decimal have different rules. And again, I've never seen a scenario where this didn't work. Now, let's quickly go through these example numbers and see how many sig-figs are in each one. And I listed the reasons why. I didn't hide those from you. So 123.45. That has a decimal present, so you start counting from the left. 1, 2, 3, 4, 5. It's got 5 sig-figs. If it's a non-zero, it's always counted because it's there for a reason. There is a measurement there. Now 103, there is no decimal there, so the decimal is absent. Start counting from the Atlantic, from the right. You count 3, 0, 1. Now even there is a 0 between the non-zeros, you still count it. So that one has 3 sig-figs. Now 130, again, it's the decimal is absent. You start counting from the right, but you ignore the zeros until you hit your first integer. So ignore that 0, and then you have 3, 1, counting from the right. So that only has 2 sig-figs. Now we're going to write 130 in scientific notation. This shows you that the previous 0 on 130 is not actually measured, because if you can put it in scientific notation and lose it, it's not significant. Now, if we want to show that that 0 is significant in the number 130, we measured that it is exactly 130, not 131, not 129, it is 130. You can show that in scientific notation by saying 1.30 times 10 to the second. That shows that there are 3 significant figures, because to count scientific notation, you count the number before the multiple sign. So there's a decimal present, start counting from the left, you count 1, 3, 0, 3 sig-figs. And again, 1.30, 3 sig-figs. You would not write that 0 after a decimal unless you measured it. It has to be significant. Now, 0.0026. There is a decimal present, start from the Pacific, start from the left. There is a 0 that doesn't mean anything, another 0 that doesn't mean anything, then 2 6. So that means that you have 2 sig-figs on that number. And then again, if you can lose that 0 using scientific notation, it clearly isn't that important. So 2.6 times 10 to the negative second, again, 2 sig-figs. Now 1 dozen. 1 dozen is tricky, and this is not on the AP test, and it will not be on any of your unit tests or anything that you're going to be graded on, but this is something that's interesting to know. If you have a description of a number, like 1 dozen. 1 dozen means exactly 12. There is no ifs, ands, or buts, not 12.00 or 12.0000. It is infinitely 12. There is nothing short or different about that. It is exactly 12. It's not 12.000001 or 11.99999. It is 12, exactly, no matter what. All right, that is the first video over sig-figs. Let me know if you have any questions or if you saw any mistakes in this video, and I can try and get those fixed up. But that is the end of your video.